Hey, mathematicians. This is student book page 52 called Buying Apples. And you might think that this one is a little challenging today, but that's okay. So we're going to kind of stretch our minds today a little bit. And we are going to look at equivalent fractions using geoboards, using our normal algorithm strategy for number two. And then on the bottom, we're going to look at a ratio table. We're going to try to get to a unit rate using our ratio table. So number one and two, we're actually looking at making equivalent fractions, and we're going to try to get to an equivalent fraction using the eighths. So all of these fractions today on number one and two can be simplified or made into an equivalent fraction using eighths. So what we're going to do for number one is color in the geoboards to show the fractions below. Each geoboard represents one whole. So on the first one, I'm going to count. I want to figure out how many little squares there are in each of these holes so I can assess and figure out how many I need to shade in each time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each of these geoboards has 16 squares, okay? And we're going to shade these in according to the fraction here. I'm going to write the equivalent fraction of each of these in eighths and sixteenths, okay? So I know that half, you're thinking, Mr. Mack, I know how to shade in half. Yes, we do know how to shade in half. We're going to make a line through the halfway point. I'm using green here. See if my green stays with me. The ink looks like it's already running out. So I might have to go to blue. We're going to be going blue instead of green. Okay, so there's half. Now I want to write out the equivalent fraction of this half as well. So there's two ways that I can write this. I can write this as 1, 2, 3, 4, 5, 6, 7, 8. There's 8 out of 16 shaded in. And I can also write this as, I can simplify this down to eighths as well. So if I half the 16, I can make it eighths, right? 16 divided by 2 is 8. So whatever I do to the bottom, I have to do to the top. So if I half the 8, I get 4. So 1/2 is equivalent to 8/16, which is equivalent to 4/8. Does that make sense? All of the numerators here are half of the denominator. 1 is half of 2, 8 is half of 16, and 4 is half of 8. They're all the same. All right, 1/4. So now I'm going to cut my geoboard into fourths. So I'm just going to make my lines going down a little bit darker so I can see that the specific fourths on each of these. So I have 1, 2, 3, 4. 1, 2, 3, 4. I'm going to shade in one of those. So I'm just going to shade in 1/4. Okay. Now we're going to write the same thing again. We're going to write these equivalent fractions over here. So I have how many sixteenths? 1, 2, 3, 4, 4 sixteenths. And how many eighths do I have? Well, if I divide the 16 by 2 again, if I just half the 16, I get 8. If I half the 4, I get 2. So 1/4 is equivalent to 4 sixteenths, which is equivalent to 2 eighths. Okay. All the same fraction, just looks a little different. Okay, now we're going to go to 3/4. I am going to cut my geoboard into fourths again. I just like to make a visual so I can actually see each of my fourths. So I have 1, 2, 3, 4. 4 different parts. You could have also gone across, right? I just like to go down. I don't know why I like to go down first. So I'm going to shade in 1, 2, and 3. There's my 3/4. Okay, now let's make our equivalent fractions. So how many sixteenths do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 sixteenths. And let's make this into an eighths again. So remember, if I cut my 16 into half, I get eighths. Whatever you do to the bottom, you got to do to the top. 12 divided by 2 is 6. So 3/4 is equivalent to 12/16, which is shown here, which is equivalent to 6/8. Okay, so now for the bottom row, D, E, and F, they are already split into eighths. So what we know about 16ths and eighths, then we can figure this out. So I know it's 1/8, so I'm going to actually, since we already know that there's 16 squares here, I'm going to change 1/8 into 16ths. Does anyone know how to do that? We can just double it, right? So we can do the inverse or the opposite of going from 16ths to eighths. We can double the eighths to go to 16. So 1/8 times 2 gives me 16ths. Whatever you do to the bottom, you got to do to the top. So 8 times 2 is 16. 1 times 2 is 2. So 1/8 is equivalent to 2/16. So now I can simply shade in 2 of my 16ths. So that is 1/8. That is equivalent to 1/8 of the total squares. This is 2/16 is equivalent to 1/8. Okay, let's do the same thing with 2/8. So I'm going to change my 2/8 into 16ths by doubling both the numerator and denominator. So we're going to say 16ths. 8 times 2 is 16, and then 2 times 2 is 4. So 2/8 is equivalent to 4/16. And if you notice, the problem B right above this shows us that. We did that already, didn't we? So 4/16 is equivalent to 1/4, right? So that's the same fraction. 4/16 is equivalent to 1/4. And that's like saying, okay, if I have 16 students in my class, 16 students, and I say, okay, I want 4 of you to come with me outside real quick. That means I asked 4/16 of my class to come outside with me, and that's 1/4 of the class, which makes sense because 16 divided by 4 would be 1/4, or 4 kids. All right, so 5/8. So we're going to do the same thing. We're going to double the 8, double the 5. So I have 16ths again, and I'm going to 5 times 2, which is 10. 10/16. 5/8 is equivalent to 10/16. So now I'm just going to count out 10. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. 10/16 is equivalent to 5/8. Okay, so let's look at number 2. We're going to go through these, and it says add the following fractions. If the sum is greater than 1, write the answer as both an improper fraction and a mixed number. So the way that they are showing us how to do this is to write it as a mixed number first and then as an improper fraction, which is fine. We can actually, we're going to do it the other way around. So I'm noticing all of these have 8 in common. So we're going to change all of our fractions to eighths. So we're going to change 1.5 to something 1 and something eighths plus 3/8. Okay, 1.5 we're going to rewrite as 1, and if we remember up here on A, half is equivalent to 4/8. Remember, 4 is half of 8, so 1.5 is equivalent to 1 and 4/8. And 3/8, we can stay the same. Since it's already eighths, we don't have to do anything to the 3/8. We can just rewrite it over here in this square or this line here. Now we just add a cross. So 1 and 4/8 plus 3/8. So I'm going to put my 1 over here, my 1 whole. Now I'm going to add 4/8 plus 3/8. So I just add the top line, the numerator, 4 plus 3, which is 7, and the eighths stays the same. So 1 and 7/8. And how we write that as an improper fraction, we multiply the 8 times the 1, which is 8, and then you add the numerator. That's kind of the algorithm. You multiply and then add. It's kind of a circle. 8 times 1 plus 7. times and plus. So 8 times 1 is 8. And then 8 plus 7 is 15. So 1 7/8 is equivalent to 15/8. So that's like saying if I have 2 pizzas cut into eighths, and if I had 16/8, that would be 2 whole pizzas because 16 divided by 8 is 2. But if I have 15/8, that means one person ate the pizza. We only have 1 7/8 left, or 15 slices left out of the 2 total pizzas out of the eighths. Okay, 2 1/4. So we're going to write 2. We're going to change the 1/4 into eighths. Okay, and remember for B, let's look at 1/4. We're looking at the fraction here, 1/4. Oh, let's see. Oh, okay, that changes to 2/8. Remember, 2/8. Okay, so we're going to write 2 1/4 as 2 2/8. Plus, okay, it's already, we don't have to change anything. It's already eighths plus 2/8. So now we're going to say 2 wholes. And then since we already moved the 2 over, we're going to say 2/8 plus 2/8, and that is 4/8. So 2 plus 2 is 4, and the 8 stays the same. So this one, we're going to say 8 times 2 plus 4. So remember the algorithm to find the improper fraction, 8 times 2 plus 4. 8 times 2 is 16, and then 16 plus 4 is 20. So that's my numerator. And the denominator stays the same. Always stays the same. Eighths stays the same no matter what your fraction looks like. So 2 4/8, or 2 1/2, that's equivalent to 2 1/2, is the same as 20/8. Okay. So if I have pizzas that are split into eighths, and if I have a pizza that is split into 8 pieces, and then into eighths, sorry, equal slices, and then I have 20 of those, that's what that would mean. I have 20 of those slices. Okay, bottom one, 3/4. Do we have a 3/4 up top? Oh, we do. Okay. So 3/4 is equivalent to 6/8. So we're going to change 3/4 here to 6/8. And we're going to take away 2/8. The 8 stays the same, and we just subtract the numerator. 6 minus 2, which is 4. 4/8, which is equivalent to 1/2, isn't it? Okay, so pause the video if you need to for that, and then we're going to move on to number 3. So this ratio table is a little different. So we have to go for this ratio table and find the unit rate. So number 3 says 5 pounds of apples costs $8. Use the ratio table to find the cost for 9 pounds and 11 pounds. You do not need to use all of the table cells. So in this case, when it's asking us to find the cost of pounds for $9 and $11, there's no easy way to get there from the 5. Remember, ratio table is nice because we do the same thing for the top and the bottom. But when we're at a 5, it's not divisible into 9 or 11. So what I want to do is try to find how much money it costs for 1 pound of apples. Okay, so what is the price for 1 pound? And then after we find that, then it's easier to find any amount for any pounds we want, like 9 or 11. So the easiest way to do that is to first we need to go up to Mr. Mac's favorite number in math, which is 10. So what we're going to do is we're going to take our pounds, because I notice we're at 5 right now. So we're going to go up and double 5 to get to 10 pounds. So let's figure out how much it costs for 10 pounds first. And I'm doing this because I can get from 10 to 1 pretty easily over here. And we're already at our unit rate then, okay? So there's a strategy here. We're trying to get our unit rate of 1, but we have to go up to 10 first. I think that'll be easier if we do it this way. So let's double the 5 to get to 10. And so that means we're going to have to double the 8. 8 times 2, is 16. So for 10 pounds, it costs $16. We went up on that one. Now, I want to get to the cost of 1 pound. Now, the cost of 1 pound, I have to go backwards. So, what's the opposite operation of multiplication? It's division. So, to get from 10 to 1, the way we do that is we divide 10 divided by 10. 10 divided by 10 is 1. Whenever you divide the number to itself, it's always 1. Because if you do the inverse of that, 1 times 10, it's going to be 10. So 10 divided by 10 is 1. So now we're at 1 pound. So we're going to have to divide 16 divided by 10. Okay? Now, Mr. Mac, how did we do that? Well, 16 divided by 10, let's see. If I write 16 divided by 10 down here, I notice that 10 is not divisible into 16. We can't do that evenly. So there is going to be a decimal, isn't there? Whenever you divide a number by 10 or 100 or 1,000, I'm going to show you a quick trick. What you do is, so if I look at 16, there's always a little decimal at the end of a whole number. There's an invisible decimal at the end of every single number. At the end of every single whole number, there is an invisible decimal, and you can put zeros at the end of those numbers, as many as you want. Now, when you divide a number by 10 or 100 or 1,000, doesn't matter, but whenever we divide by the power of 10, let's say, I'm going to take that decimal and I'm going to move it to the left or move it one place value over. So the 16 now becomes 1 6/10 or $1.60. Now, if it was 16 divided by 100, let's say, if it was 16 divided by 100, well, I have my invisible decimal here at the end of the 16. And if it was 100, I have two zeros or two place values, powers of 10. Now I would move my decimal to the left 2 times. 1, 2. So it would be 16 cents or 16 hundredths. If it was 1,000, if I was dividing by 1,000, well, we would take the same decimal, we'd go 1, 2, 3. And the decimal would be way over here, but there's no number in this little loop, so we'd have to fill that with a 0. If it was 10,000, do the same thing. 1, there's 4 zeros, right? Or 4 powers of 10 place value. 1, 2, 3, 4. Wow, it would keep going. The number just keeps getting smaller and smaller. You just keep adding zeros. Same thing can be said for whenever you multiply a number by a power of 10, you just remember you can just add a 0. They say add a 0, but you're really just moving the place value. So 16 times 10, it's the exact same thing as we just did. You're just making it bigger. So you're adding a 0. So it's 160. If it was 100, you just add another 0. 1,000, another 0. 10,000. So you're doing the same exact thing when you multiply, you're going to the right. But when you divide, you're going to the left when you have powers of 10. So anyway, when we're back to 16 divided by 10, if I write 16 in our little spot here for the ones place, if I put my invisible decimal at the end of my 16, I know I'm divided by 10, so there's 1 0. So I'm going to move the place value, my decimal, to the left one spot, not to the right. We're not multiplying. It's not 160, but we're moving it to the left, making the number smaller. So my new number is 1.6 or 1 6/10 or $1.60. So one apple costs $1.60. And this is important when we're trying to get up to 9 and 11. Okay, so now we can work. So, and let's go up to, let's just do 2 now. Let's go up to 2. So I'm going to double the 1 to 2. I'm going to double the $1.60. I'm just going to tell you what it is. It's $3.20. Should we double it again? Let's double it again. Let's go up to 4. So times 2 again. So now we're up to 4. I'm going to double this. I'm going to double the 320. So that's 640. Okay, so now let's see what numbers we have. See if we can figure out 9 and 11. Do we have anything down here that can get me to 9? Remember, 9 pounds. That's what I'm working with. Oh, I noticed something. If I add 5 plus 4, that gets me to 9. Or I could say 10 minus 1. That gets me to 9. Let's do the addition one. So we're going to take this column here, the 5, in this column over here, the 4, and add those together. So 5 plus 4 is 9. Now I'm going, since I added the bottom 2 columns, I'm going to add the top 2 columns. So I'm going to add $8 plus a dollar. Geez, Mr. Mac, $8 plus $6.40. Notice how I put 2 zeros at the end of my $8? Because I did that so it makes it easier for me to see where my place value is and easier for me to add. So 0, 4 plus 0 is 0. My decimal just follows in line all the way down, and then 8 plus 6 is 14. So 9 apples cost $14.40. Can I fit that in there? Here, I'm going to make a little line because Mr. Mac is getting messy. This is what happens in math. It's okay. So 9 apples or 9 pounds cost $14.40. Is there any way I can get up to 11? Because now we're up to 11. Do we see anything here that I can combine to get me to 11? Oh, I think you saw it. I have a 10 and a 1 right there. These 2 columns right here, 10 plus 1. So I have my 11 column, 10 plus 1. So I'm going to add 16 plus $1.60. So I can do this in my head. I can add 16 plus 1. That's 17. And then the 60 cents just hangs out on the end there. So $17.60. And I can write that in my space here. All right, so I'm telling you, it's a little challenging, isn't it? But if you're able to follow along with Mr. Mac on that one, great job. And I hope that this makes sense. We're going to do some more ratio tables later, but remember, unit rate is the main thing for this one to remember. Get down to the 1 pound per price.